In this video, we will look at how to find the equation of a line in y equals mx plus b when you're given 2 points. Now, on the right side, I have the steps laid out for the algebraic way, but I will show you a more visual way where you use a graph to calculate the slope and the y-intercept. Now, if we are doing this in an algebraic way, it all starts off with the slope. We know in y equals mx plus b, we need the slope and we need the y-intercept. And the slope, we have a nice formula for it. y2 minus y1 over x2 minus x1. So that's what we're going to do. I'm going to label my coordinates x1, y1, x2, y2, and just plug them into my formula. So y2 minus y1 means 7 subtract y1, which is -2, so a double negative there. And then x2 subtract x1, again a double negative. The double negative will turn into addition, so we really have 7 plus 2 is 9, 2 plus 1 is 3, and this reduces to a slope of 3. The minute you have the slope, we can plug it into y equals mx plus b for m. And now it goes back to a previous concept. Now we have the slope and you have 2 points to choose from. So pick one of your coordinates, whichever one you want, and sub it in for x and y to solve for b. So really, the only thing that's different from finding the equation of a line between a slope and a point and this scenario is that you have to find the slope yourself first. But after that, the algebra is the same. Now I'm going to pick the coordinate 2, 7 because there are no negatives. So instead of y, I'll put 7. And instead of x, I'll put 2. Just like before, we do our multiplication first. 3 times 2 is 6. And then we can bring that 6 to the other side, switching the sign because we're trying to isolate for b. And 7 minus 6 is 1. So that means our final equation is y equals 3x for the slope and then plus 1 for the y-intercept. So I did my slope formula and I put my slope in for m. Then I used my point, put it in for x and y to isolate for b, then put it all together. And that's the algebraic way. If you like a more visual way, all we're going to do is plot our 2 points and connect them with a ruler properly and carefully. If you're off here, it messes everything up. So our first coordinate is -1, -2. Here it is. And 2, 7. Here it is. Now we connect the dots with a ruler. So I'll try my best on here. Okay, here we are. That's our line. So if you connect it properly, right away you should be able to see your y-intercept, which is 1. Then for your slope, you do have to create a right triangle and do rise over run. So I'm just going to use my coordinates and I'm going to count. 1, 2, 3 for the run, 1, 2, 3, 4, 5, 6, 7, 8, 9 for the rise. So that my slope, rise of 9, run of 3, that's 3. So then I can take those 2 pieces of information and write the exact same equation I just came up with algebraically. But again, you have to plot your points properly. You have to connect them with a ruler. If your line is wonky, you're not going to see the right y-intercept. So be careful. You can also mix and match these methods. So plot the points to get your slope and then do the algebra for your y-intercept. The choice is yours and the grid is there for you if needed. Let's try another one, and I'll do them in both methods once again. So I have my coordinates. Step 1, let's find the slope. So label x1, y1, x2, y2. And how about you pause the video here and just find the slope, and then come back to check. So for your slope, you should have 4 minus 2 for the y's, 3 minus 1 for the x's. 4 minus 2 is 2, 3 minus 1 is 2, and that simplifies to 1 for our slope, which means our equation is going to be y equals 1x plus b. If you made a mistake somewhere, check to see, are your y's on top, are your x's on the bottom, were you careful with signs and order? All right, so slope, check. Now, pick one of your points. It doesn't matter which one. I'm going to use 1, 2. I'm going to say 1 is x, 2 is y. And now again, pause the video, plug your values in for x and y and isolate for b, put it all together, then come back to the video to check your work. So for y, we're going to put 2. For x, we're going to put 1. 1 times 1 is 1. And bring that 1 over to the other side. Careful that you change the sign. 2 minus 1 is 1. So our equation is y equals x plus 1. Technically, you can write y equals 1x plus 1 if you prefer, but if the coefficient is just 1, it's not necessary to write. So there it is. Let's say you plotted your points. So why don't you go ahead, plot your 2 points. So here we are. When I connect my points, first of all, I don't hit the y-axis. I can extend my line, or I can find my slope first, which I'm gonna do. I rise 2, I run 2, so my slope is 2 over 2, which is 1. And then when I continue my line, I can just apply that slope. Go down 1, run 1. And now I see my y-intercept is 1 as well. So either way is perfectly fine. Practice both methods before you choose one. The algebraic method might just help you more for future calculations. If you're comfortable with algebra now, it could help you moving forward. All right, let's try again. So our coordinates are 6, 4 and 2, -2. So let's find our slope. And just throughout this process, pause the video, try something on your own, then come back to check your work just to see if you're on the right track. And on the next one, I'll let you do it fully on your own. So we're going to find the slope first. So if you'd like to pause here to try it on your own, that would be great. The y's are subtracted, the x's are subtracted. Be careful when you simplify. -2 minus 4 is -6. 2 minus 6 is -4. This does reduce to a positive 3 over 2. So that means y equals 3 over 2x plus b. At this point, we do have a fraction, so we are going to have to be careful here. Choose whichever point you want and sub it in. Again, if you'd like to pause here and try it out, go for it. I'm choosing 6, 4 for my x and y. So for y, I'll put 4. For x, I'll put 6. Now, because I do have a fraction, I'm going to put the 6 over 1, so that when I multiply, I don't do something silly. 3 times 6 is 18. 2 times 1 is 2. That does reduce to 9. So make sure you reduce it or you make your life harder. Bring the 9 over, switching the sign. And we get -5 for b. And then we can put it all together. 3 over 2x, subtract 5. So there's the algebraic method. If you want to try the visual method, again, pause the video, try it out, see if you get the same values. So 6, 4 is here. 2, -2 is here. I'm going to connect and find my slope. 6 for the rise, 4 for the run. So 6 over 4, which is the 3 over 2 that we got as well, so that's good. And then personally, you can extend the line with your ruler, or to be a little more accurate, I'm just going to apply my slope. So obviously going up 3 and then to the right 2 is just going to take me further from the y-axis. But I'm just going to go down 3 and then to the right 2, and there's the -5 for b. So same equation, either works. All right, I want you to try C fully on your own here. So pause the video, choose whatever method you prefer, then come back to check your work. So I'm going to start with the algebraic method. My slope is going to be y2 minus y1, x2 minus x1. So -9/3. When you simplify, use a calculator if you have to, so you don't do something silly. But our slope is -3, which means we have y equals -3x plus b. That's half of the puzzle done. Pick a coordinate, plug in for x and y. I'm going to pick the positive coordinate. So instead of y, I'm going to put the 5. Instead of x, I'm going to put the 1. And now multiply. -3 times 1 is -3. And bring it over. Don't forget to change the sign. That's a common mistake that can happen, so don't be that person. And put it all together. Y equals -3x plus the 8. So there's the algebraic method. If you chose it, the visual method, here's 1, 5. Here's 4, -4. I'm going to connect my dots, find the slope first, and then I'll apply it backwards. So that's -9 going down, and then 3 to the right. So when you are using the visual way, you do have to pay attention to the direction of your line, or you can mess up on your slope. If you say 3 instead of -3, wrong. Now I'm going to apply my slope. So instead of going down 3 to the right one, because that's kind of useless because it takes me further from the y-axis, I'm going to go up 3 and to the left one to get to 8, which is what we got algebraically as well. So if you did that correctly, awesome. If you made a mistake, see where you went wrong, take note of it, highlight it, star it. Don't make that mistake in the future. All right, last one. So pause the video, try this one. Think of all the mistakes you might have made. Don't make them again. Be super careful. Then come back to check your work. Okay, so our slope, 5 minus -1, 10 minus -5. You should have 6/15. We are going to be stuck with a fraction, but reduce it. Both of these are divisible by 3. To get 2/5. So y equals 2/5x plus b. Now I'm going to choose the positive coordinate, so 5 in for y and 10 in for x. Because my slope is a fraction, put that 10/1. 2 times 10 is 20, 5 times 1 is 5. This does reduce to 4. And when we bring that 4 over, 5 minus 4 is 1. So that our equation, y equals 2/5x plus 1. So if you got that and you did the algebraic method and everything went right, that's awesome. Now I'll go through the visual way. So -5, -1 is here. 10, 5 is here. Use a ruler to connect the dots. If you use a ruler, you should be able to actually see your y-intercept right now. Looks like it's 1, but I'll double check as well. My rise is 1, 2, 3, 4, 5, 6. And my run, 5, 10, 15. So my slope, I got the exact same 6/15, and I'll remember to reduce it. And even though I connect my dots, I am going to double check my slope by applying my slope to this coordinate here. So rise 2, run 5, and I did get 1. So the double check is just to make sure that my line didn't go wonky when I connected the dots. But that's it. Use your coordinates to find the slope using the slope formula or the visual and counting rise over run. Then to find your y-intercept, either apply your slope to your graph or plug in a point and isolate for b.